Good morning. This lesson is for my Integrated 1 classes and my Honors Integrated 1 classes, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this lesson, but I'm going to title it how I title it in the title. But what I am sure of is our one goal for the day. And our first and only goal is to solve systems of equations by graphing. The first example we're going to see is doing this when the equations are in slope-intercept form. That's example 1. And the second example is going to be when the equations are in standard form, example 2. Now, before you continue with this lesson, I hope that you watched my review lesson on how to graph lines. I'm going to go over very quickly how to graph lines, and so you might be missing some steps. So if you find that you struggle graphing lines, hit pause, go watch my other lesson on how to graph lines in these forms, and then come back and watch the video. Or if you watch the video and you're finding that you're having problems graphing lines after the fact, go back and watch the video on how I do that. Now, let's go ahead and talk about a little bit of a review. Any point on the line is a solution. So every line has an infinite number of solutions because every line has an infinite number of points on it. Alright, so if you have a point on the line, it's the solution to the equation for that line. It's very important to understand that. So here I have a little picture, and the question I want to ask is, what does the following show? So I have a line that's going this way, I have a line that's going that way, and they cross right there. So maybe hit pause and see if you can figure out what they show. Hopefully you hit pause and figured out what they show. And if you did, I'm back. And so what this shows is this is a point that is a solution to both of these lines. So the point where the lines cross is a solution to both. All right, so I want to elaborate this a little bit. So when we solve equations by graphing, we want to find where the lines cross because that is where we have a solution to both equations that the lines represent. I just repeated myself, which I like to do. Anyways, let's move on to the solve by graphing examples. Now, the main problem with solving by graphing is you could draw the graph off a little bit. And when it's off a little bit, you might not get a true representation of the solution. So if in an ideal world, you would solve this by transitive or substitution or Gaussian elimination. But we do need to know how to solve these by graphing. So when you graph, you're going to want to use a ruler and be as accurate as you can. I don't have a ruler that I can use, so I'm going to, you'll see how I use the slope to continue the pattern. All right, anyways, I'm going to solve example 1 by graphing, and here I have two equations in slope-intercept form. So I already know my M and my B, and I'm going to use those to graph. So the red equation, I begin at 4 on the y-axis. So I'm going to put a dot at 4 on the y-axis. My slope, or my M, is -2/1. And so this tells me how I'm going to move to my next point. So I'm rising in the negative direction, so I'm going down. And I'm running in the positive direction, so I'm going to the right. So from here, I go down to right 1. Down to right 1, I'm going to put a dot. And so normally I would just have you guys connect those dots and move on. But I'm going to just keep using this down to right 1. Down to right 1. Down to right 1. Down to right 1. And I can even go up to and left 1. You can change that pattern according to the sign rules for a fraction. So this red line represents that red equation. It's another representation of it. So again, my equations are in slope-intercept form, so I already know my b value and I already know my slope. So my second equation, my b value is -2, so I begin at -2 on the y-axis. I'm going to put the negative up top. My m is equal to -1/2. So I rise in the negative direction, run in the positive direction. So from here, I go down 1, right 2. Down 1, right 2. And now that I know that my lines are crossing, I'm just going to draw them, and that was terrible, but they should have, try it again. It should have crossed right there, and that is 4, -4, and that's where my lines are crossing. And if I was to plug in a 4, I'd get a -8, -8 to 4 adds to 4, that's my y value, so it works in the first equation. The second equation, if I plug in a 4, I get half of 4, which gives me a -2, -2 minus 2 is a -4 for my y value. So this is a solution to both of these equations. And we found it by figuring out where the lines cross. All right, moving on to example 2. Example 2 is in standard form, and again in the previous video, I go over how to graph these things. And so what we're going to do is we want to put them in slope-intercept form, and we're going to do that by first subtracting the x value to the other side. That cancels out. I'm left with 3y equals -1x plus 3. These are not like terms, so I cannot put them together. And I'm going to divide away that 3. And I get my equation y equals -1/3 times x plus 1. So again, like before, I can figure out my b value and my slope. So my b is 1. So I begin at 1 on the y-axis, and I'm moving, let's see, -1/3, so down 1, right 3. So down 1, right 3. Down 1, right 3. I can also go up 1, left 3. Right? So this is going to be the line that represents the red equation. I need to also put this equation in slope-intercept form. So again, like before, the first thing we're going to do is we're going to move the x's to the other side. What a squeaky pen. I get 1y equals -2x plus a 4. I'm going to divide away, oh no, it's a minus of 4. It's a minus of 4, there you go. I'm going to divide away the 1, and y equals -2/1x minus a 4. Again, I can figure out my b. b is -4, so I begin at -4, 1, 2, 3, 4. And I'm moving -2/1, so I'm going down and to the right. And let me make sure I'm still on this screen, because I hate having to do these things. Oh, and I'm on there. Wonderful. I hate having to reload. All right. So from here, I go down 2. Let's see, down 2/1. Well, I'm going away from this line. So maybe if I go up 2, left 1, up 2, left 1, up 2, left 1, then I'll hit my line. So these lines, it looks like they cross at -1, 2, 3, and +2. -3, +2. -3 makes that -3. +2 makes that 6. -3 and 6, that equals 3. So that's the solution to that equation. -3 makes this a -6. -6 plus a 2 is a -4, and it's the solution to this equation. So these are two examples on how to solve systems of equations by graphing. Essentially, you're putting both graphs on this, or both lines on the same graph, and you're finding out where they cross. All right, so we saw how to do this with slope-intercept form. We saw how to do this with standard form. And again, you can see that I just kept continuing my slope pattern until they crossed, because again, this is not very accurate. So I'm going to go ahead and end this one here. Again, I hope everyone is doing all right out there. Have a great day, everybody. That was terrible. Bye-bye.